Okay, today we are looking at arithmetic sequences. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. Basically, what I like to think of is you're adding or subtracting the same value every single time. So these are probably one of the easiest ones that we're going to do. The common difference is that difference that's added or subtracted each time, the numerical difference. We use the letter D to represent the common distance. So the letter D. As far as the examples go, let's look at that. So notice on this first one we have, let's see, find the common difference in the next four terms. Okay, so notice here they're adding, how many are they adding? If I subtract that out, they're adding 8. Okay, so adding 8, did that work here too? Yes. Notice each time we're adding 8. So our D is 8. And if they want the next four terms, let's see, that would be 69, 77, 85, and 93. I kind of need to make that larger because not a lot of room right there. Okay, so on this next one, looks like they're subtracting 3 each time. So that's minus 3. So next three terms would be negative 22, negative 25, negative 28, and negative 31. Okay, the next one, they're obviously subtracting the same thing each time. They're subtracting, what is that, 14? So D is negative 14. So the next four terms, let's see, if I subtract 14, that would be negative 45, negative 59, negative 73, and negative 87. And you can use your calculator if you need to. Let's see, the next one they must be adding. So if I subtract this out to see what they're adding, oh, that's 19. So the D is 19. So for adding 19 each time, the next term would be 83, 102, 121, and 140. Alrighty. So the next part is the formula for it. Well, I like this formula. We kind of introduced it a little bit in the last lesson, and that is the a sub n, the nth term, can be found by taking the first term and then adding D, your common difference, n minus 1 times. So it's pretty straightforward, easy to remember, at least I think it is, where D is your common difference, a sub 1, of course, is your first term. So notice, like on these examples, on number 5, we're adding 6 each time. So I see D is 6. So if I want the, what is that, 32, the 32nd term, then a sub 32 would be the first term, which is 7, and I'm adding 6 31 times. It's always one less than the one I'm looking for. And what does that come up to be? Let me check. So 6 times 31 plus 7, 193. All right, so the next one, what is that, the 24th term that they're looking for? Or common difference here, what are they doing? They're subtracting 11. All right, so minus 11 each time. So to find the 24th term, I take the first term, which is 4, and I'm subtracting 11 23 times. So let's see what that gives us. 4 minus 11 times 23, negative 249. All right, the next one, they are adding 4. So my D would be a 4. So the 45th term would be taking the first term, which is negative 23, and I'm adding 4 44 times. So it's really not too terribly difficult if you remember the formula. And to me, it just makes sense. So it's not hard for me to remember this one. Oh, let's see, the last one. Oh, I kind of got marks in front of it. Let's see, what are they adding? If I subtract that out, they're adding, no, they're subtracting negative 2.5 each time. So that's our D. So to find the 39th term, I take the first term, which is negative 3, and I'm subtracting 2.5 38 times. So negative 3 minus 2.5 times 38 gives me negative 98. I like this so much faster than having to go all the way down the line like we did on those recursive formulas. All right, so now on these, we are going to use what we know about arithmetic sequences to figure out the missing parts. So notice on the first one, they're saying that a sub 1 is 29, the difference is 7, and we want the 36th term. So that means we have, let's see, to get to the 36th term, we take the first term and we add 7 35 times. And then after that, it's just a matter of plugging in the formula there. So that would be plugging in our calculator, and I believe you get 274. See the next one. Oh wow, this is kind of going backwards, because notice they're giving us a sub 22, but we need to find the first term. So let's see, the 22nd term is negative 156, and that's equal to the first term minus 9 21 times. So now I have an equation and I can solve this. So what's 9 times 21? That's 189. So negative 156 is equal to a sub 1 minus 189. And if I add 189 to both sides, I think that gives me 33. So the first term would be 33. All right, so let's look at number 11. First term is 11. 25th term is 107. Find D. Okay, so we know the 25th term, which is 107, would be equal to the first term, which is 11, plus our D 24 times. So now we just have to solve this equation. So we just subtract 11 first, and then divide by 24, and D is 4. Okay, so number 12, first term is 5, 18th term is negative 199. We want the 13th term. Ooh, okay, let's see. I know the 18th term, which is 199, would be equal to the first term, which is 5, plus my D 17 times. So first thing I'm going to do is find the D, so then I can use that to find the 13th term. So if I subtract 5, that gives me negative 204, and that's equal to 17D. So divide by 17, that gives us negative 12. All right, so D is negative 12. And that's helpful because that's what I need to find the 13th term. I know it's the first term minus 12 times. So that gives us negative 139. So notice how these are kind of like little puzzles. You've got to figure it out based on the information you go. So you've got to be familiar enough with it to do that. So number 13, the nth term is negative 76. First term is negative 21. The common difference is negative 5. Okay, so the nth term can be found, well, we know what the nth term is, so I'm going to go ahead and put it in as such. If I can get that to erase. There we go. Okay, so negative 76 would be equal to the first term, which is negative 21, minus 5 n minus 1 times. So now we have this equation to solve. So I'm going to add 21 to both sides. That gives me negative 55 equal to negative 5 times n minus 1. Now I'm going to divide by the negative 5. Well, I could do it that way. Yeah, if I divide by negative 5, that gives me 11 equal to n minus 1, and then add 1, so n is 12. Okay, and the next one, the nth term is 310. First term is negative 15. D is 13. Find n. Okay, same basic concept here. 310 would be equal to negative 15 plus 13 times n minus 1. So add 15 first. That gives me 325. And I can distribute here. Let me do that on this one, because The other time I didn't, and just in case that's something that you would prefer, if you want to actually distribute, first, you get the same answer, so it doesn't really make a difference. So that means I would add 13 here. That'd be 3, 3, 8, go to 13 in, and divide by 13 is 26. So n is 26. So it doesn't matter if you divide by that 13 first and then add the 1, or distribute that 13 and then, because you get the same answer either way. All right, last little part on this page, where we're going to write explicit and recursive formulas for each sequence. I personally like the explicit, but you need to be able to recognize the others and know what they are. So let's look at it. What are they doing each time? Oh, notice they're adding 2. Sweet. And you might want to check, you could check a few of them, make sure that that's consistently what they're doing. So this means our explicit formula would be a sub n is equal to the first term plus 2 n minus 1 times. So pretty straightforward. I like that one. The recursive one is a little bit different. That would be the nth term is equal to the term in front of it, which is a sub n minus 1, and then plus 2. And you always have to say, well, wait, I wrote that wrong. A sub 1, the first term, is negative 19. Okay. On the next one, notice here they are subtracting, 6 each time? Yeah. Okay, so explicit formula would be first term minus 6 n minus 1 times. The recursive one would be the term in front of it minus 6, and then I have to specify what my first term is. Okay, this last little bit looks at arithmetic means. And these are the terms between any two non-consecutive terms in an arithmetic sequence. So for example, like if we have this particular sequence that they've given us right here, this one, then to find the arithmetic means between 8 and 32, well here's 8, here's 32, they are 14, 20, and 26. It's just the numbers in between them. So if you know that they are arithmetic, that's important, and you know how many means you're looking for, it's easy enough to figure it out. So like on number 17, we have 50, and we want 3 means, so I'm going to draw 3 blanks here, and then the last one's 118. So now I got to figure out what they are. Well, I'm going to use what I know. For instance, I know 100 to get to 118, we take the first term, we add our common difference 4 times because there's 4 steps there. 1, 2, 3, 4. So I can solve this and find out what the D is. So I'm going to subtract the 50. That gives me 68 equal to 4D. Divide by 4, I get 17. So D is 17. So that means those numbers that go in these blanks, if I add 17 each time, I'm going to get 67, 84, and 101. So these are the 3 means that we're looking for. So on number 18, we're going to start with negative 16. We want 5 this time. So 1, 2, 3, 4, 5. Oh, I'm running out of room. I should have wrote smaller. Oops. Let me see if I can make that go away. There we go. Okay, so that's the last term. So I know negative 58 would be equal to negative 16 plus my D. How many times? 1, 2, 3, 4, 5, 6. 6 times. So if I solve this equation, let's see, that add 16, that would be negative 42 equal to 6D. So D is negative 7. So that means each time I'm subtracting 7. So my terms, or my answers, let's see, that would be, if I subtract 7, I'll go ahead and put them right here. That's negative 23, negative 30, negative 37, negative 44, and negative 51. So there they are. All right, so let's look at the next one, number 19. Oh, 7 means. We'll have to write small for this one. Okay, so 17, 1, 2, 3, 4, 5, 6, 7, and then 5. All right. Okay, so let's see. I know the 5 would be equal to 17 plus our common difference, 8 times, right? Yeah, 8 times. Oops, I'm back on the marker. There we go. 8 times. Okay, so this would be negative 12 equal to 8d. So that's negative 1.5. You can write it as a fraction if you like. So I got to subtract 1.5 each time. So my answers are going to be, I'm just going to write it down here since I've got room, and those will be very squished in up there. 15.5, 14, 12.5, 11, 9.5, 8, and 6.5. Well, I guess I could have wrote a little bigger. So these are the answers there to number 19. And then this next one, only 4 means yay. Okay. Oh, wow, these numbers are big. So 2, 2, 6, 5, and then 4 spots. And then 3, 5, 7, 0. Okay, so 3, 5, 7, 0 is equal to the first term plus d, 1, 2, 3, 4, 5 times. So if we solve that equation, we get 1305 equal to 5d. Divide by 5. Oh, wow, you want to use your calculator on that one probably. That's 261. Okay, so that means I'm adding 261 each time. Wow, okay, so that would be 2526, 2787, 3048, and 3309. There we go. Awesome. Okay, so now let's look at a couple application problems and see how we may see this on a test. Okay, so on number 21, a theater has 35 seats in the first row, 39 seats in the second row, 43 seats in the third, etc. Write both an explicit and recursive formula to find the number of seats in the nth row. Okay, so they're starting with 35, and the next one's 39, and then 43. So what are they doing? They're adding 4 each time, right? So that means a sub n would be equal to the first term plus 4 n minus 1 times, which is your explicit one. That's the first one that they get asked for. Second one, recursive, that would be the term in front of it, which is a sub n minus 1, and then you're adding 4, and you have to specify that the first term is 35. All right, that one wasn't so bad. Okay, 22, Ryan weighed himself at the end of each week by into his new diet. Table to the left shows his weight at the end of each week for the first 3 weeks of his diet. Write an explicit rule to find his weight in weeks into the diet, and then find the weight after 16 weeks. Of course, we know you're not going to lose weight steadily, or might not, especially not the same amount each time, but we're going to pretend that it is. So let's see, from there to there, what is it that he's losing 1.7 pounds each time, right? So minus 1.7. You're just going to subtract them on your calculator and see what it comes up to be. So that means the nth term is taking the first term and subtract 1.7 n minus 1 times. So there is our explicit rule. And then they want, what is it in 16 weeks? If you continue this pattern, then we just plug in, let's see, 256.3 minus 1.7 times 15, and I think you get 230.8 pounds. All right, let's look at this last one. On Anna's birthday, her grandma gave her a check to open a college savings account. Her grandma continued to send checks on her birthday, each at the same amount. At 7 years old, Anna's grandma had given her a total of $610. At 18 years old, the grandma had given her a total of $1,270. How much money did Anna's grandma give her on her first birthday? Let's see. Well, at 18, she gave her $1,270. And at 7, it was $610. All right, so I'm going from the 7 to the 18 because that's what I know. So the 18th one is equal to the 7th one plus D 11 times, because there's 11 steps between there. 11 steps. So let's see, that would give us 660 equal to 11D. So D would be 60. Okay, so every year they're doing 60 after the initial one. So what's on the first birthday? I don't know. Let's see. Let's go with the closest one to it. So the seventh one, which is 610, would be equal to the first term plus 60 6 times. So 610 is equal to a sub 1 plus 360. So that means 250. So she gave her 250 initially, and then $60 every year. Alrighty, we're done. Yay.